Hello everyone, welcome back. Here's VanAmsen. Today we will be diving deep into the problem max number of key sum pairs. So it's a medium difficulty problem on LeetCode, and trust me, it's an interesting one. So let's get started. Here is a brief overview of the problem. We have an integer array, nums, and an integer key. And in one operation, we can pick two numbers from the array, those sum equals key, and remove them. And the task is to return the maximum number of such operation. So let's clarify this with a quick example. If num is 1, 2, 3, 4 and key equals 5, the answer would be 2. Why? Because we can remove 1 and 4 and 2 and 3 from the array, and simply right, so it's just two operation. So now let's dive into the code and see how we can solve this problem. All right, so let's start coding this solution. We will use Python for this one, but remember, the logic can be replicated in other programming languages, and you will find those implementation in the description below. So we have a max operation function that take parameter num and key. So step 1, we will count the occurrences of each number. So step 1, count occurrences of each number. Frequency map, and for num in nums, frequency num will be frequency get num 0 plus 1. So here we are counting the occurrences of each number in our input list num. So we store this count in a dict called frequency, and the get method is a quick way to do this. So next we will initialize our counter for the number of operation. So count will be 0, and step 2, traverse through the unique number in the dictionary. So for num in frequency, if num times 2 equal key, then number is half of key. So count plus 1 frequency, integer division by 2. Okay, so now the interesting part. We traverse through the unique number in our frequency dictionary, and step 2 is traverse through the unique number in the dictionary for num in all frequency. So if a number is half of key, we can form pair from the number itself. For instance, if key equals 4 and we have two 2's, we can form one pair. So let's code this as well. So frequency 0 and set its count to 0 since we have used it up, and else key minus 1 num in frequency, and form pairs and update the count of both numbers. So it will be pair equals minimum of frequency num frequency key. Okay, so we have set our counter to 0 since we have used it in frequency num 0, and otherwise if the complement of the number, so key minus num, exists in our frequency, so it's a complement, we can form pair and update the count of both numbers. So we have done a purse, minimum frequency, and now let's implement the rest of the logic. So count will be plus per, and frequency num will be minus per, and frequency key minus num will be minus per, and we return count. Okay, so that's it. And finally, we return our count. So yeah, let's run it for these two examples to verify everything work. So yep, array 1, 2, 3, 4, key 5, 2 pairs, all good. So yeah, the second example is also correct. So key 6 and just 1 pair in array of 3, 1, 3, 4, 3. Awesome. So we have coded our solution to find the maximum number of key sum pairs in a given list. So now we can submit it to verify how fast it is. So hopefully it will work. Yeah. So all working, and we have beaten 94% with respect to runtime, and also 41% with respect to memory. So it's quite good. And yep, so it's an efficient solution. So there was even on the left tail even faster solution. So yeah, interestingly, what approach was taken, but I think like our implementation is really efficient. So we have just coded solution. So we use a frequency directory to help us keep track of numbers and their counts, and then traverse it to find pairs. So it's a neat approach, efficient, and quite intuitive once you get the hang of it. So that's it for today's coding session. If you found this video helpful, please consider giving it a thumb up. It's really help, and sharing and subscribing for more content with tutorials, coding, and much more. And also don't forget to check out the code in other languages in the description below. And happy coding. Keep practicing. See you in the next one.